By the time the consequences became visible, the organization had already been remade from the inside. Machines that had once embodied precision were now symbols of compromise. Production lines hummed efficiently, but inconsistencies were mounting quietly, almost imperceptibly. Financial instruments grew in complexity at a pace no engineer could fully track. Risks were assumed, traded, and consolidated across divisions, leaving gaps that were invisible to anyone focused on short-term targets. General Electric had invented modern industrial discipline, but now it had to explain itself to regulators, investors, and the public. What appeared as normal operational activity was, in reality, a company negotiating its own limits, with every metric carefully presented as proof of control. The appearance of stability was convincing, until the cracks repeated and compounded. For a long period, almost nothing seemed wrong. Plant managers reported on-time outputs. Quarterly statements looked strong. Shareholders saw growth. Engineers still solved complex problems. Yet the cumulative impact of small compromises had begun to erode authority. Each adjustment, each trade-off, was reasonable when taken in isolation. Each one preserved short-term efficiency, but together they were reshaping the organization's very capacity to intervene. By the time the scale of compromise became clear, reversing it was no longer a technical challenge, it was a structural impossibility. For most of the 20th century, General Electric was not a typical corporation. It was a technical institution where engineering competence determined authority. Engineers didn't merely design components, they defined the bounds of feasibility. Schedules adjusted according to the demands of physics. Budget constraints mattered, but only after design certainty was established. A single failure in a critical system was unthinkable. This culture was not born out of caution. It was forged in the understanding that machines fail publicly and catastrophically when neglected. Industrial systems that powered cities, transported millions, or regulated entire infrastructures cannot tolerate compromise. Minor shortcuts do not stay minor. They propagate. They escalate. They leave traces that echo long before the public ever notices. For decades, this awareness defined General Electric's identity. Precision was non-negotiable. Trust was earned slowly, defended aggressively, and treated as the company's most valuable asset. Success was measured by reliability, not speed. Engineers were the guardians of limits. Managers who did not respect those limits were marginal, not influential. Culture was the system's primary safety measure. Every line of code, every assembly process, and every test protocol reinforced the belief that failure could be anticipated, mitigated, or prevented. This belief was embedded in the corporate DNA, and for years it served the company well, producing machines and systems that shaped the modern world. But the environment outside GE began to change. Capital markets demanded faster returns. Competitors emphasized short-term gains. Conglomerates were no longer lauded for engineering accomplishment, but for operational efficiency. The valuation of complexity shifted from technical achievement to measurable financial metrics. The definition of success quietly evolved from durability and performance to speed, predictability, and risk-adjusted returns. The organization didn't announce this shift. It implemented it incrementally, through incentive structures, promotion criteria, and subtle redefinitions of priority. The metrics that once captured reliability now captured efficiency. Engineers remained, but authority started to migrate to those who understood the language of finance better than the language of limits. The shift wasn't catastrophic at first. Performance metrics improved. Earnings became smoother. Management systems were praised for rigor. Yet each step forward came with subtle compromises. Margins were adjusted, production schedules compressed, tolerances widened. These were not errors. They were decisions aligned with new priorities. Each decision seemed rational, responsible, necessary. Only when examined collectively did the emerging pattern hint at fragility. Engineering logic became an input to financial logic rather than its guiding principle. What had once been absolute limits were now treated as negotiable assumptions. Risk was no longer inherently dangerous if performance metrics were met. As authority drifted away from the engineers, pressure intensified in new forms. Growth expectations were no longer abstract. They were enforced rigorously, quantified for every unit and division. Underperformance became a career risk. Managers, incentivized to meet financial targets, gradually absorbed engineering concerns into schedules and budgets rather than acting on them directly. Reviews that once scrutinized design limits instead assessed compliance with metrics. The culture of saying no to unsafe assumptions began to fade. When an engineer objected, the system responded not with intervention but with discussion, mitigation, and a cautious willingness to proceed. Control remained, but it was softer, slower, and distributed across a bureaucracy that did not fully understand what it had inherited. Decisions became incremental and iterative. A slight relaxation of tolerance here, a minor adjustment in a component there, a schedule compressed by days. Each change was small, almost invisible, but each compounded across departments and product lines. None of these steps appeared dangerous in isolation. The problem was cumulative. The system had trained itself to treat risk as manageable as long as numerical targets were met. Engineering authority was subordinated not by malice or negligence, but by an organizational rhythm that prioritized measurable outputs over judgment calls. Gradually, a system that had been designed to stop itself from harm now facilitated its own exposure. For a time, this system functioned. GE continued to grow, to deliver impressive quarterly results. Market analysts lauded its management practices. Internally, teams felt the cadence of success. The outward appearance of control masked the internal accumulation of risk. Oversight became focused on metrics rather than material conditions. The company rewarded efficiency, not caution. Complex systems were monitored financially rather than operationally. This gave a sense of stability, but the stability was contingent. It depended on assumptions that had not been stress-tested and conditions that were increasingly unrealistic. The cracks didn't announce themselves dramatically. They appeared as anomalies, small deviations in performance that were explained away as minor disruptions or statistical noise. A turbine slightly underpowered, a batch of components delayed, a financial instrument yielding unexpectedly. Each instance was minor, easily justifiable, almost invisible. Yet when layered over thousands of processes and decisions, the aggregate effect began to manifest in ways that no single engineer or manager could address alone. The system, built for precision, had become a network of compromises. What had once been a single line of defense, engineering authority was now diluted across reporting chains, committees, and metrics dashboards. The very mechanisms that ensured oversight had become instruments of delay. In some divisions, engineers continued to raise concerns, quietly. They highlighted potential failures, questioned assumptions, and pushed back against deadlines. These interventions were noticed, acknowledged, but increasingly marginalized. Solutions were reframed to fit the new paradigm. Budgets were adjusted, schedules recalculated, risk models updated. Nothing was ignored outright, yet the weight of authority had shifted. Their objections no longer commanded the halt of production or a re-examination of plans. Compliance replaced judgment. Documentation replaced intervention. Expertise existed, but it no longer defined action. As authority drifted, pressure escalated not as overt crisis, but as subtle urgency. Competitors advanced, markets fluctuated, and shareholders demanded consistency. The company responded through systems, rankings, internal reporting, performance matrices. Each measure seemed rational, even necessary. Yet rationality here was incremental. Pressure did not arrive as catastrophe. It arrived as a cadence of expectation, a drumbeat that every unit had to match. Compliance became synonymous with survival, and the cumulative effect was an organization moving at cruising speed toward outcomes that no one could fully anticipate. Engineering excellence became increasingly procedural. Risk assessments were quantified and incorporated into financial forecasts. Design adjustments were justified in spreadsheets, simulations, and projections. The instinct to stop or to push back against a decision became, over time, a luxury few could afford. Every new financial goal, every market expectation, subtly eroded the instinctive boundaries that had once governed the company's most critical operations. A system designed to prevent failure now accommodated it rationally, incrementally, and invisibly. This is where the story of drift becomes especially difficult to grasp. It did not feel like failure while it was happening. It felt like progress. Each unit met its targets. The company posted growth. Management systems functioned. On paper, the organization remained exemplary. Engineers were still solving complex problems. Yet the invisible architecture of authority who had the final say, who could enforce limits, had quietly transformed. Control had moved from technical certainty to managerial confidence. Decisions were vetted less by what could fail and more by what could be justified. For a while, the illusion of stability persisted. The market celebrated GE's efficiency. Executives pointed to smooth earnings, rising stock prices, and continued operational output as evidence of mastery. Inside, teams believed in their ability to manage complexity. Each adjustment, each compromise, seemed temporary, isolated, and manageable. Yet these temporary solutions were stacked upon one another, across years, divisions, and processes. They created a web of dependencies that no single intervention could unravel. Then subtle failures began to appear. Not catastrophic, not immediate, but enough to raise unease. A plant failed to meet a production metric. A unit reported slightly higher defect rates. Financial instruments produced results that were inconsistent with underlying assumptions. Each anomaly was explained, documented, and adjusted. Nobody sounded an alarm, yet the pattern was emerging. Small deviations accumulated into systemic fragility. The organization was no longer failing in discrete units. It was failing across a network of processes, with consequences that could no longer be predicted by the engineers who remained at the front lines. Internal culture adapted to this reality. Reporting replaced intervention. Meetings replaced decisions. Risk was addressed in theory rather than in practice. Engineers were still respected in name, but in function, authority had migrated to the systems designed to optimize output. These systems were rational, efficient, and highly effective, but they were no longer tuned to prevent failure. They measured performance, not safety. They assessed metrics, not limits. And for all the expertise retained, the organizational reflex that once prioritized restraint over efficiency had quietly disappeared. By the time visible signs of collapse could no longer be ignored, the company faced a new challenge: understanding what had happened. It was not obvious, not dramatic. It wasn't a single event that could be traced to a single decision. It was the product of decades of incremental shifts, of authority redistributed, of subtle compromises normalized, of performance incentives that quietly overrode the judgments of those trained to anticipate failure. The engineers remained. The systems remained. But the combination no longer guaranteed reliability. And this is the uncomfortable truth. GE did not fail because it lost talent. It failed because it lost the ability to let talent control the outcome. Expertise remained, but the authority to act on it had dissipated. What once prevented collapse now merely delayed it. When the pressure finally intersected with these hidden weaknesses, the consequences arrived uneven, unavoidable, and undeniable. As the external environment began to notice irregularities, GE faced scrutiny it had long avoided. These weren't immediate catastrophes. They were signals, faint but persistent, appearing in financial reports, regulatory inquiries, and public statements. Investors began asking questions about returns that no engineer had signed off on, about divisions that underperformed despite robust projections, about assumptions that once seemed safe but now appeared stretched. Each answer was framed with precision, backed by analysis, yet each left a lingering doubt. The explanations were technically sound, yet they only deepened the sense that something vital had shifted. Internally, engineers continued to operate with diligence, yet their influence had eroded. Decisions still passed through technical review boards, but the boards increasingly functioned to document choices rather than to challenge them. Risk mitigation became a formality, a box to check rather than a boundary to enforce. Each concern raised required additional approval. Each objection had to be reconciled with financial imperatives. Slowly, the rhythm of caution was replaced by the cadence of compliance. The expertise was present, but it no longer dictated the path forward. Pressure escalated further, not as a visible crisis, but as a series of subtle nudges that accumulated into compulsion. Divisions were expected to meet targets even when technical uncertainty was high. Forecasts were adjusted to align with investor expectations rather than engineering reality. Managers interpreted data to show achievement, even when assumptions were stretched. Authority had migrated, incrementally, from those trained to say no to those trained to justify progress. The company still functioned. In fact, it functioned remarkably well, which made the fragility harder to detect. Gradually, the cumulative effect of these shifts began to manifest in operational friction. Maintenance schedules became more aggressive, tolerances were widened, and interdependencies that once had robust safeguards were left exposed. Small failures, a turbine slightly misaligned, a minor software glitch, a production delay became signals of systemic strain rather than isolated errors. Each one was explained, adjusted, and logged, yet no single failure could stop the momentum. The system that once enforced limits now accommodated deviations. When these deviations converged, they produced outcomes that were visible to the outside world. Investors questioned results that no longer aligned with historical reliability. Regulators began deeper reviews of processes that had once been benchmarks for the entire industry. News outlets started reporting anomalies as isolated incidents, never quite capturing the underlying pattern. And inside GE, there was awareness, but no single point of control remained capable of halting the progression. The organization's reflex to prevent failure had been diffused across incentives, dashboards, and committees. This was not a sudden reckoning. It was a slow, quiet unspooling of assumptions that had once been considered immutable. Engineers continued to design, calculate, and verify, yet their authority to stop operations or demand reconsideration was limited. Management logic efficiency, predictability, shareholder returns overlaid engineering judgment, and the system, by design, prioritized continuity over restraint. The tension between competence and authority, between expertise and final decision-making, had been normalized. Even as challenges grew, internal communication emphasized rational explanations. Each failure could be justified, each anomaly had a rationale. And so the organization continued, believing itself in control, unaware that control had already shifted. The company's legacy decades of engineering excellence remained intact in practice but diminished in power. Expertise existed, but it could no longer veto decisions that financial imperatives demanded. Then, the visible consequences could no longer be ignored. Units failed to meet expectations in ways that had ripple effects across divisions. Financial instruments produced outcomes misaligned with assumptions embedded in their design. Public confidence wavered, regulatory pressure increased, and media narratives began to question the reliability of the company that once set the standard. Yet through all of this, the engineers remained in place. The machines worked. The products continued to function. What had failed was the system that ensured safety and authority were aligned. This is the central discomfort of the story. Failure was never a dramatic event. It was a slow erosion, invisible to all but those tracking subtle divergences. It was a handoff of authority from those trained to prevent error to those trained to optimize output. And by the time the public, the market, and regulators could observe the consequences, the pattern had already become entrenched. Engineers were still solving problems, but they no longer defined the boundaries of what was possible. And the lesson that remains unresolved is this: institutions built to manage complexity can quietly redefine their own limits without anyone noticing until the moment those limits intersect with reality. The engineers are still there, the systems are still functioning, and yet the ability to intervene decisively has quietly evaporated. The question that lingers, unspoken, is whether such a system can ever recognize the moment it has ceded control, before the consequences become irreversible.